Hey guys, it's time for our next lesson, so make sure you grab your notebook. When you watch these videos, you should have your notebook open out in front of you, and you should be taking down notes. So if I write something down, you write something down, so you have everything in your notebook. This document will be a PDF in the lesson for you, so if you want to use Cami to take notes on it, you can, like we practiced in class a little bit. You can give that a try. If you have a printer at home, you can print a copy of this paper for you to have as well too, or just simply grab your notebook and put your notes in there. Either way, write stuff down. All right, today's skill is one-step equations. It's a review lesson for you. It shouldn't be anything new for you at all. Let's take a quick review. So we're going to start with the adding. Oh, so first of all, just equations. Equations in general. What's the goal of equations? The whole goal is to isolate the variable. We're trying to get that variable by itself. That is the whole point of it. And how do we do that? We use inverse operations. So instead of adding, we use subtraction. Instead of multiplying, we use division. We just do the inverse operation to both sides. Remember, equations have to balance. So whatever I do to one side, I have to do to the other side so that my equation stays balanced. That's a really critical piece for it. And then does it make sense? We should be able to take our answer, plug it back into the equation, and it should work. And then we know that we're on the right track. So let's take a look at some of these adding and subtracting ones. So the first one, 3 plus x equals 8. If I take a look at that, my equation, that equal sign divides it between a left side and a right side. So I always want to keep those balanced. If I do something to one side, I have to do it to the other side. So is my x isolated? It's not. My x is not by itself. What's keeping it from being by itself? The plus 3. So I need to get rid of that plus 3 by doing the opposite. What's the opposite of plus 3? Minus 3. So I'm going to do minus 3 to one side, minus 3 to the other side. What am I left with? X on one side and 5 on the other side. So I end up with x equals 5 for my solution. I should be able to take that x, I should be able to plug that back in here and check to say 3 plus 5 equals 8. It does. So I know I have the right answer. Next one. Oh, that's right. I forgot there's a faster way to erase this. New technology to get used to. All right, next one. 8 equals x plus 3. So again, I have my left and my right-hand side. You don't have to draw that line if you don't need it. As we get into the more complicated equations, it might help you, but it doesn't have to be there. So what's keeping the x from being by itself? Again, the plus 3. So again, I'm going to subtract 3 from both sides and end up with 5 equals x. Is it okay that the x is on the right instead of on the left? Sure, it's absolutely okay. It's not a problem at all to be able to do that. Let's see, Alt Z. It worked. Next one, 9 equals x minus 3. We're going to isolate the variable. What's keeping the x from being by itself? It's minus 3. The opposite of minus 3 is add 3. Of course, what I do to one side, I have to do to the other side. So this time I get 12 equals x. And again, it's okay that the x is on the right-hand side rather than left-hand side. It's okay. You can leave it 12 equals x. You don't need to move it and make it be x equals 12. Next one, what's the difference between this one and this one? What's different? See it? Right? It's just minus 4 instead of minus 3. So what do you predict the answer should be? Right? Make your prediction. Let's check and see if you're right. So there's plus 4 and plus 4. So we get 13 equals x. Was your prediction right? Good job. Good for you. Okay, let's take a look at a few more. Oops. Erase. This. There we go. Now we can move it up a little bit. Right? How about if we add some integers in there? Some of our negatives in there. So the opposite, we have a negative 6. So the opposite of negative 6 is plus 6. So we add plus 6 to both sides. We're left with x on one side. And then we have negative 7 plus 6 is negative 1. So x equals negative 1 for our final answer on that side. Integers. Okay, if I have negative 7 and I have 6, I have more negatives than positives, so my answer is going to be negative. That should make sense. And again, I can take that negative 1, I can plug it back in here to check. Does negative 1 plus negative 6 equal negative 7? It does. So I have that correct. Next one. What's keeping the x from being alone is a negative 14. So we're going to add 14 to both sides. We're going to add that to both sides. So x is now isolated. It's now alone. And then on this side, we have negative 32 and positive 14. Should my answer be negative or positive? Negative, right? I'm expecting negative because I have more negatives than positive. And you can use your calculator if you need to. You'll end up with negative 18. All right, how about the next two? There's a fraction in them, but we're not afraid of fractions. We can do fractions. We have our calculators to help us with it. Take a look at this one. What am I going to do? What do I have to move? At negative 7. How do I get rid of the negative 7? Add 7 to both sides. So I have x on the left, and then I have 7 plus 1/2. 7 plus 1/2, not hard, right? It's 7.5. Whoops. Easy for me to write. Easy for me to say, but hard for me to write. 7.5. Right? What about the next one? What do we have to do? All right, if we get rid of that 7, how do we get rid of that 7? Let's just subtract 7 from both sides. So I have x. What about 1/2 minus 7? What's that? Use your calculator if you need to, but think about it. If I have negative 7 and I add a half, I get negative 6.5. All right? That's adding and subtracting. Quick review of that. How about multiplying and dividing? Let's take a look at those. Multiplying and dividing looks like this. A few of you made mistakes when we did the words to know. When you were writing it, it was a product of 3 and a number. A product of 3 and a number would look like this, would look like the 3x. Whenever we write multiplication, we don't use the dot. We don't use we don't use this. We don't use the dot. We just will write them next to each other like 3x. When they're right by each other, that means multiply times each other. And we always put the number first and then the letter after it. We never do this. We never do that. We never put the variable first and then the number. It's always the number first and then the variable. So just a little detail to figure out that one, right? So this is multiplication. The opposite of multiplying is to divide. So I'll draw the line. Divide by 3. Divide by 3. I get x equals 6. X equals 6 for that one. How about this one? What's keeping the x? We have to isolate the variable. That's the goal. What's keeping the x from being alone? So divide by 3 and divide by 3. So you get x equals 5/3. Is it okay that it's a fraction? Yeah, it's absolutely okay. A lot of times your brain will go, wait a minute, something doesn't make sense, because it usually turns out to be really pretty. It usually turns out to be a whole number, but it won't always be a whole number, and that's okay if it's not. It totally works that way. All right, look what's next. X divided by 3 equals 5. That's divided by. Fractions are division. That's what they are. So how do I get rid of division? The opposite of division, the inverse, is to multiply. So I'm going to multiply by 3, multiply by 3. And really that's 3 over 1. We don't write whole numbers over 1, but that's really what we're doing. And if you write it that way, I wrote it that way on purpose so I could show you what we're really doing is we're canceling those 3's out. Those 3 cancel, so I'm left with just x. Then I have 5 times 3 is 15. Just wrote that way so you could see it. All right, next one. Same thing. We're going to multiply by 3. It's really 3 over 1 is really what we're doing. Multiply this side by 3. Negative 5 times 3. A negative times a positive. If you maybe you've never seen this before, this is how I learned how to do this. Make like a little robot man, and he has negative eyes and a positive mouth. So it looks kind of sad. I don't know if this will help you with integers or not. This is how I learned integers. I think a robot man. So if I have a negative times a negative, you kind of cover those up. You want to take your thumb and kind of cover those up. I'm going to cover them up. A negative times a negative, what do I left? I have a positive. If I have a negative times a positive, those right there, if I covered those up with my finger, a negative times a positive, I'm left with a negative, so my answer is negative. So you kind of cover up the 2 that you have, and whatever's left is what your answer is. So a negative times a negative gives you a positive mouth, and a negative times a positive gives you a negative mouth. Maybe that helps you. So a negative times a positive, we cross up negative times positive, we're left with a negative. So my answer is negative 15 equals x. And again, the x can be on the right-hand side. It's okay. We really want it to be on the right, but it can be on the left. It's okay. All right, moving down to the second row. Give those ones a try on your own and see how you do with those. Go ahead and pause this video and give those a try. No, really, pause the video and give them a try. All right, how did you do? How do we do? So this is division. Opposite of divide is to multiply. We're gonna go times 4. We have x equals 32. Next one, we're gonna multiply by -4. Multiply by -4. What you do to one side, you do to the other side. You gotta balance them. That gives me x equals -32. This one is 17x, that's multiply. So the inverse operation is to divide. So divide both sides by 17. And you get x equals, what do you get? 6. Yep, x equals 6. This one is a division, so we're going to multiply. It's 24. And we get x equals 54 times 24. You grab your calculator and it turns out to be 1,296. Great, and we're almost done. Try the next 4. 4 more to go. Pause the video, give them a try. All right, did you pause the video? Make sure you pause the video and give them a try. It'll help you so much more if you work through them on your own first before you watch me do them. All right, you should have tried by yourself in your notebook, write them down. All right, first one, adding. The opposite of adding is subtracting. So minus 34. That gives me x equals 102. Next one is multiply. The inverse of multiply is to divide. So I get x equals 4. Next one is subtraction. The opposite of subtraction is to add. So you get x equals 170. And the last one is dividing. So we're going to multiply by 34, multiply by 34. Those cancel. We get x equals 4,624. We're good? Thumbs up. Okay, if your thumbs up, move ahead to the practice. If your thumbs down or sideways, make sure you get with me and ask questions to get prepared. Off to do the practice, and then you'll do the brain check. I'm cheering for you. You guys can do this.